Hello again. This video is on the distributive property. The distributive property starts becoming hugely important in middle school because there's going to be some algebraic expressions. That just means an expression, a math problem that has variables in it. But there's going to be some of those where you have to do the distributive property in order to simplify it, to make it more simple, to make it easier to look at, easier to work with. You're going to have to use the distributive property. Also, it can come in really handy in doing mental multiplication. The way I do some bigger multiplication in my head is actually using this distributive property. So let's get started on it. So the distributive property, my students immediately call it rainbows, and I'll show you why. It kind of looks like I'm making rainbows, but we usually just yell the rainbow property. What you do is you multiply the number that's outside the parentheses by each term or number that's inside the parentheses. So here's how you can use this for mental math. 9 times 23. Now, some of us, we can do that multiplication the way it is. We can work through 23 times 9 in our heads without it killing us if you're pretty strong at multiplying. But when I do it, this is what I do. I rewrite the problem, okay? I keep the 9 on the outside, but instead of doing 23, I know that 23 is the same thing as 20 plus 3 more, right? So here's why I call it rainbows. You take the number outside times each number inside. I know that 9 times 20 is 180 plus 9 times 3, I know that's 27. And when I add those together, I get 207. Now, I wrote it down so that I could explain what I was thinking through, but in real life, I would have just reasoned through 9 times 20 is 180, 9 and 3, that's 27, add those together, 207. Let's do another one of those. So I'm going to change 38 to 30 plus 8. Rainbows, 7 times each one of those. 7 times 3 is 210. Keep the plus. 7 times 8 is 56. I know that when I add those together, I get 266. Now, even though I told you I use the distributive property when I multiply, which is true, I would have done this one differently. 38 is actually closer to 40 if you round it, right? So instead of saying 30 plus 8, can anybody guess? I rewrite it as 40 minus 2. And then I do my rainbows. And again, I'm writing it out so that you can see what would be going on in my head. But in reality, I'm just thinking through all this. I'm not actually writing it down. 7 times 40 is 280. Keep the minus. 7 times 2 is 14. And I know when I subtract those, I get 266. So like anytime you're doing mental math, it's kind of just personal preference, how you want to reason through this. The distributive property isn't required, but it's an option. Just like the commutative property to rearrange your numbers when you're adding and multiplying, it's not required, but it's an option to make it easier. Or the associative property to regroup the numbers, not required, but an option to make it easier. Let's do a couple more of those. So let's see. I'm going to keep the 14. Now the 12, when I round that, it's closer to 10. So personally for me, I would do 10 plus 2 more. If you would rather do 20 minus 8, there's nothing wrong with that. It's just whatever your brain sees first. Now do your rainbows. 14 times 10 is 140. Keep the plus sign. 14 times 2 is 28. And I know when I combine those, I get 168. Let's do one more. 13. Now, if you want to do 10 plus 9, you can. I know, kind of thinking ahead, that 13 times 9 is not one that I know off the top of my head. Yeah, I could think through it. But mental math, the goal is to do it as fast and easy as possible. So I think for me, it would be easier to do 20 minus 1 because I know I could do 13 times 20 real fast, and I know I could do 13 times 1 fast. 13 times 20, well, I know 13 times 2 is 26. Tack on a 0. Keep the minus. Just remember we're doing rainbows. 13 times 1 is 13. let's see, 260 minus 10 is 250, minus 3 more, because it was a 13, is 247. Again, not required for multiplying or for mental math, just an option. Now, when it is required, like I mentioned a few minutes ago, is when you're simplifying algebraic expressions. I know saying algebraic expression sounds pretty intimidating and scary. An expression we've talked about before, it's just a math problem. Algebraic means it has to do with algebra, so you've got a variable or a few variables in there. That's all. When you have problems set up like these that I'm going to show you, you have no choice. You have to use the distributive property. In the next section in this unit, we're not only going to use the distributive property, but we're also then going to simplify the whole expression. So I'll explain better what it means to have like terms and to combine like terms. But sometimes before you can move forward and do any of that, you have to do the distributive. So right now I have 5 times, and I know it's times because the number's right beside parentheses, x plus 2. X plus 2 cannot be simplified anymore. Sometimes I'll have students rewrite x plus 2 as 2x. That's not the same. Or they'll look at that as x and 2 more, so that's 3x, but they're not the same. X and 2 are not like terms. That means they don't have the same variable. You can't have an apple and an orange and say how many apples you have altogether, because an orange can't be added with those apples. I can't say an x and a 2 and how many is that all together, because an x and a 2 are not the same thing. It's just x plus 2. So we're going to take this number outside and multiply it by each term or part or number inside. 5 times x, all you do is write 5x. Keep the plus. 5 times 2 is 10. It's all about those rainbows. Don't forget to do your second rainbow. A common mistake is to put 5x plus 2, but just putting one little loop up there looks kind of dumb to call it a rainbow, right? We need at least 2 of them for it to actually resemble a rainbow. Now, one way that you'll see me explaining some of these here in a bit, when we start throwing in negative signs, up till now, I've just been saying keep the plus or keep the minus, this one that's in here. However, I'm going to kind of shift gears now, and I'm going to explain it this way, because like I said, it's going to help when we hit the negatives. 5 times x is 5x. And then I have a positive 2 plus add positive. They're really all the same thing. So I'm going to take 5 times a positive 2 and a positive 10 is what I get. So I write plus 10. I know that doesn't seem very necessary right now, but when the negatives are in there, it'll help you if you kind of train your brain to see that as a positive 2, not just a plus 2. Let's do another. So I'm going to take the number outside times each thing inside. Inside, I have a 4 and I have a negative x. Negative and minus really represent the same. So I'm going to do my rainbow. I need 2 of those to make it kind of resemble a rainbow. 3 times 4 is 12. 3 times a negative x is a negative 3x. So you want to put minus 3x. Let's do another. On this next problem here, inside parentheses, I have a 2a and a positive 5. I'm going to take the number outside times each number inside. 8 times 2a, well, 8 times 2a is 16, and then just stick an a on it. 8 times a positive 5 is a positive 40. And remember on these, folks, we're not combining our answers. That 12 minus 3x is not the same thing as 9x. They're not like terms when one of them has an x and the other one doesn't. 16a plus 40, that's not the same thing as 56a because one of them has an a, but one of them doesn't. Let's do another one here. I've got a 10 outside. Inside, I've got a 1, and I've got a minus 3m. 10 times each one of those gives me, let's see, 10 times 1 is 10. 10 times negative 3m is negative 30m. I know it can probably drive you crazy to leave your answers like that because they look so unfinished, but you will get much more used to it. As we get into more algebra problems, you'll start seeing a lot more answers that look like these. It's not always going to be just one nice, neat, simple answer, simple number. Okay. You can also do the distributive property if the lone number, the guy that's by himself, if he comes after the others. We're just going to make backwards rainbows. And it doesn't matter if you do 4 times the x first or 4 times the 6 first, as long as you're remembering to watch for whether those are positive or negatives and how that affects your answer. It doesn't matter which rainbow goes first. 4 times x is 4x. 4 times a positive 6 is a positive 24. So what I was saying was that if you did 4 times 6, now I know that says positive, but don't put plus 24 in the beginning. Your plus or your minus only goes in between when it's a case like that. So 24, and then 4 times x is a positive 4x. That would be okay. Remember, addition's commutative, so both of those mean the same thing. If I can remember to write my x, sorry. Let's do another. So inside I've got a y and I've got a -2. I always go to the one on the far left first, just because that's my personal habit. When I was your age, I had an easier time not missing negative signs if I always went to that one on the left first. And I don't know if it really made a difference, but to me, I feel like it did. So I just always kept that habit. 11 times y is 11y. 11 times a -2 is a -22. The alternative to that would be to have a -22 plus 11y. Last one on this page. Inside, I've got a 7 and I've got a positive 3x. So I'm going to take 8 times each one of those. 8 times 7 is 56. 8 times a positive 3x is a positive 24x. The alternative to that one, if you did your rainbows in the other order, would be a 24x and a positive 56. Okay? Now, earlier, I mentioned that it's important to train your brain to think about how a negative and a minus really represent the same. We also need to keep in mind that when we're multiplying by negatives, if your two signs match, remember they buddy up and they form a positive. That especially becomes important when the number that's by himself outside happens to be a negative number. We haven't done any like that yet. That's when the signs can start to become really tricky. So let's do a few of those. On this first one, inside I've got a positive 4x and I've got a positive 1. Rainbow, rainbow, multiply, multiply. -9 times 4x is -36x. -9 times a positive 1 is a -9 or -9. Now, if you did it this way, if you wrote -36 plus -9, that's okay. Oh, I forgot my x again. Sorry. The only thing is the proper way to write your answer when you have two operation signs right beside each other is to separate with parentheses. Okay, let's do another. Inside, I've got a 7 and I've got a 7x. Multiply, multiply. -2 times 7 is -14. -2 times 7x is a -14x. Or if you have -14 plus -14x, that's okay. Just put the -14x in parentheses. Now, if you don't put the plus, don't go ahead and put this guy in parentheses, because without a symbol in between those, that would mean multiply, right? So only put the parentheses if you have two signs right beside each other. If you did them in the other order, you could have -14x minus 14 or -14x plus parentheses -14. Let's do another. Inside, I've got an x and I've got a +1 or a +1. Number outside times each number inside. -12 times x is -12x. -12 times 1 is -12. Or if you put plus parentheses -12, that's okay as well. I want to do just 3 more to get a little more practice. What I would encourage you to do at this point is to hit pause on the video and try these 3 and then resume the video and see if we match. Okay? All right. So inside I've got an X and I've got a -4. Rainbow, rainbow. -3 times X is -3X. -3 times a -4, watch out here. Negative times a negative becomes a positive, right? Negative times a negative becomes a positive 12. If you had done this, -3 times X is -3X. Keep the minus. -3 times -4 is a -12. If you had written it that way, it's not wrong, but I would probably write a note back to you that says to clean it up a little bit, because this I've tried to teach you to think of like a big flashing neon sign that should just be glaring you in the face. It's a face problem, right? And it's never as simplified as possible to leave it that way. It's always better when you have minus and negative to go ahead and rewrite that as a positive. So this is your best answer right here. Let's try another. Now, if you feel like after seeing that one, if you tried these on your own, if you feel like maybe you need to adjust the next 2, go ahead and pause again and do that, and then resume and see if you corrected them in the right way. So inside on this one, I've got a -5X and I've got a -6. Rainbow, rainbow. -1 times -5X is a positive 5X. Since that's the first thing I'm writing, I don't need to put plus 5X. I'm just going to put 5X. -1 times a -6 is a positive 6. Last one. Inside I have a 3 and I have a -X. I'm going to rainbow, rainbow. Now remember I said I always go to the one first that's on the far left. It doesn't mean you have to, so I'll show you both ways. Going to the 3 first. -5 times 3 is -15. -5 times a -X becomes a positive 5X. If you had gone in the other direction, -5 times -X is a positive 5X. -5 times 3 is a -15. And see, no matter which way I write it, I still had a negative sign that stayed with my 15. And my 5X was still a positive. So make sure, even if you have used the commutative, is what we're really doing, and you do have them in a different order, if I have something that has a negative in front of it, you should still have that negative in front of it, no matter which order it's in. Okie doke. So that is the distributive property. Hopefully it doesn't seem too overwhelming. Some of these topics that focus more on the pre-algebra type things, they just take a little time. If this felt like a foreign language, maybe go back and watch the video again, give it another try, do some math games online, just do a search for the distributive property. There's other videos you can watch too, other lesson tutorials. Do a little research, do a little more practice on the distributive property. In my class, this is something that we will keep practicing throughout the year, and it's going to keep coming back for every math class that you take. It always shows up in one form or another. Let me know if you need my help. Thanks for watching. Hey, we actually made it through a whole video without any technical issues where my stylus wasn't writing and I didn't have to pause for any announcements at school or anything. We got through one. Yay. Thanks for sticking it out. Bye.